Hello guys, I've got another video here for you. Last one of the term, I think, and this is on area of composite shapes. So this is 11G from your textbook. Okay, these are some of my favorite types of questions that requires lots of thinking and application of different formulas, and I think they're really cool. So to start with, when we say composite shapes, or the word composite, that actually has the definition of that it's made up of different elements. So when we're talking about a composite shape, for us, that means a shape that is put together from other simple shapes. So they're usually irregular shapes. So not just a square, not just a triangle. They could be those two things put together, which is what we've got here. Or it might be a shape that is without something, so it looks like something has been cut out of it or off it. So two different kinds here. The main thing to bear in mind is when you're finding the area of composite shapes, they can be found in two main ways. So by adding or subtracting the areas of simple shapes. Okay. So for this, I'll just go through a couple of examples here for you. Can't seem to rub out anymore. Never mind. Here we've got the area of a square with a triangle sort of stuck on the end of it. And so the easiest way to find this would be to find the area of the square first, and then find the area of the triangle, and then add them together. For this example, you could find the area of the entire rectangle, including the bit that's actually not there, and then find the area of that section, which is a triangle, and take it away from your area of your rectangle. Okay? And sometimes you actually can do the question both ways, and so you would just choose one you're more comfortable with, a method you're more comfortable with, and go from there. But others you'll look at it and one will be more obvious than the other in terms of the best way to go about it. Okay, so just made a little checklist here to things to think about when you're doing these questions. So to achieve success in these questions, you need to remember the correct formulas that we've looked at. So areas of squares, rectangles, parallelograms, and triangles. Communicate these really clearly in your working, and I'm going to show you the most logical way to do that in a moment. And then make sure you're using the correct measurements for the different sides of the things you're trying to find. Because a lot of the times you'll need to make a subtraction or an addition to work out a missing side length. Or there'll be information on the diagram that you don't actually need to answer the question, just to try and trick you a little bit more. So let's do a couple of practices. There's heaps of these in your textbook, and I'd recommend trying to practice with these a lot. And don't forget, there's also those extra resources I popped on the Google Classroom too. Okay, so let's practice. This one here, it says find the area of each of these composite shapes. I've got another one to do in a minute. So this shape here is an irregular shape. It's not quite a rectangle. It looks like a rectangle, but it's had a section that's been sliced off it a little bit. And so this would be one of those situations where you find the area of a triangle, find the area of a rectangle, and including the bit that's not here, this little triangular section, and then find the area of that triangle and subtract it from your total. Okay? So to do this question, I would highly recommend that you draw onto the shape if it's in an exam, and if it's in your textbook and you're just practicing questions, draw the actual shape into your book so you can write all over it. Because what I'm going to do now is show you the working I would love to see you use. So for this question, I'm going to start by writing sort of like a rule. So area, and then in brackets I'm going to write total. And what I mean by that is my final answer equals, in this case, the area of number 1 subtracted from the area number 2. Okay, so area 1 take away area 2. Okay, So I'm going to write A1 right here in the middle, and when I say A1 for this shape, I actually mean all of this, including this little section here. Okay, so it's a rectangle. So here's one of those examples where they've got lots of measurements on there. You've got to make sure you choose the right one. So to find the area of a rectangle, so I'm going to start by saying A1. I'm just going to find that first. To find the area of this rectangle, I need to do length times width. I need to make sure I'm choosing the right numbers here. So I actually need all the way along. So this 9 measurement is only from here to here, so that's actually not useful to me right now. So my length is actually my 12 all the way along, and my width is 5. So 12 times 5 equals 60 meters squared. Okay, I found the area number 1. I'm just going to do a little line down the center of my working, and I'm going to find area number 2 now. Now area number 2 is my little triangle here, so I'm going to write A2 in there, equals. Okay, so now I've got to try and remember area of a triangle formula. Okay, so that is B times H over 2. I've got a problem here because I know my H, that's 5, because it's opposite this 5, so that's 5 as well. But I don't know this. I don't know that length. But I have some clues that can help me figure it out. So I know this is 12, and this is 9, so this length along here would be 12 if I went all the way along. So I've already got 9, so that means this must be 3. Because 9 plus 3 is 12, matching the other side that's 12. Okay, now I have everything that I need to do this part of the question. So base is 3 times height is 5 over 2. Okay, so I've got 15 over 2, and that's 7.5 meters, 7.5 meters squared. Okay, nearly there. So my area total, this is my last bit, is the area of my whole rectangle, including the bit that seems to be cut off, and that is 60. Take away the area of my bit that has been sliced off to make it what it is now, that weird looking shape. So that's 7.5. Okay, 60, take away 7.5, 52.5 meters squared. Finished. Okay, so I can see you rolling your eyes going, oh, there's so much working, I don't want to write all the numbers down. Too bad, just get over it. This is the amount of working you need to communicate your knowledge to me properly in a question like this. The main reason why I do that is if you make a little error here, for example, or you make an error here, for example, if you don't have all of this working before it, I can't give you any marks whatsoever. So I try to give you marks as much as I possibly can, if possible. Okay, let's do another question. Remember, we're going to try and label everything properly using our correct rules, listing our rules when we use them. Okay, look at this shape. This is a square, was a square before something unfortunate happened and this little wedge has been cut out. Okay, so again, we're going to find the total area of this square for this question, and we're going to then subtract, find this area of this triangle that's not there and subtract that from our total. Okay, I'll try and do some more videos with some other kinds of questions where you have to find the two areas and add them together as well. I just realized they're exactly the same sort of question, but that's okay. Okay, so area 1 and then area 2. And when I say area 1, I actually mean this whole square. It's hard to label it otherwise. Okay, so our area in brackets total equals area 1 take away area 2. Okay, let's find area 1. Area 1 equals. So you could do L times W, that means length times width, for a rectangle. That would technically give you the right answer here, but actually the area of a square we would write length squared because all the sides are the same. Okay, so in this case that means 6 squared, so that means 36 centimeters squared. Okay, found area 1, let's do area 2. And area 2 is just this little triangle. Okay, sorry, my pen is just making a gravy mess. Let's do that instead. That's area 2, that's area 1. Okay, so area 2 is our formula for a triangle. So that is BH over 2. In this case, the base is this one here, and we know because it's a square, all the sides are the same length. So that is 6. My height is listed on there as 4 divided by 2. Don't forget that step, I do that all the time. Okay, so 6 times 4 is 24 divided by 2. So we've got 12 centimeters squared. Okay, so that means we have area total equals 36. Take away 12 equals 24 centimeters squared.